Well, dear students, actually there is disturbance outside. I can't control that. But now listen carefully. The heading is resonance tube. It is a device in which we can demonstrate the formation of long stationary wave, and we can find out the velocity sound at room temperature and hence at 0 degree centigrade also. This resonance tube here consists of this metallic tube, nearly length 1 meter. Metal tube, because it is opaque, we can't see level of water here. So we have connected to a transparent tube, and here the meter scale. The tube is connected to the reservoir, of water through this tube, and this is connected here. The level of water can be seen here in this tube because it is transparent tube. This tube is transparent. Meter scale there to read the level of water in the tube. The level of water in tube changes if we lower this reservoir here. By losing the screw here, which is holding this tube, we can lower the reservoir and hence level of water can be lowered. Now, what to do? Actually, we bring here tuning fork, a vibrating tuning fork of known frequency. Generally, in our labs, we take the tuning fork n equal to 512 hertz or 480 because we need higher frequency due to limitation of length of tube. This tube is placed on this horizontal table, which has to be kept horizontally with the help of these screws. Now what we do? We lower the level of water and we can control the flow by pinch coke here. We open the pinch coke and lower the level of water and bring it suppose at this point. Now when we vibrate tuning fork here, the tuning fork vibrates like this. So when tuning fork vibrate here, it sends compression. When it comes A to B, it sends compression, and that compression is reflected back from this surface of water as a compression and goes back till that tuning fork goes from B to A and produces air fraction. And this compression is reflected back as rare fraction, and the motion of tuning fork from B to A produce again air fraction. So if this thing happens together, then longitudinal wave of large amplitude will be produced and a large sound will be heard, suppose at length L1. At length L1 we will get a maximum sound if the frequency of tuning fork is nearly equal to this air column. Resonance, I told you, the phenomena of force vibration. Resonance is the phenomena of force vibration in which natural frequency of oscillating body become equal to applied periodic force. To applied periodic force, the air is compelled to vibrate due to tuning fork, and the tuning fork send periodically compression air fraction in the air column, which get reflected from this surface of water. The surface of water here act as reed surface. And you know at this surface there is always node. If we get loud sound, at length L1, then you know frequency of this air column N equal to V by 4L. So by knowing L1 and if we know this frequency, we can find out value sound. But we have taken here second resonance condition also, because we know exactly distance between two nearby nodes is lambda by 2. And here the nodes are not found exactly at the open end, they are found little outside. So here in fact L1 plus E is lambda by 4. So it should be L1 plus E. So we have to measure E. And I told that E is equal to 0.3 D. So to know exactly V, we need to find out the E. So to avoid the measurement of and correction, what we do, we further lower the level of water. And here again we get maximum sound, but the loudness of sound at L2 is slightly smaller than at L1. Why it is? Because in this case the frequency of air column is not exactly equal to frequency of tuning fork. Here frequency of tuning fork is 1.5 times that of frequency of air column. But we get resonance loud sound whose loudness is smaller than this. In that case L2 minus L1. L2 minus L1 will be lambda by 2, or lambda equal to twice L2 minus L1, and we can avoid the measurement of E, and hence V equal to N lambda N into 2 L2 minus L1. So twice N L2 minus L1, we can find speed of sound. I have seen in laboratory that students are unable to find this condition of resonance. It is very simple, dear student. You leave the level exactly down and keep on while we do for here, level of water will gradually go down. At this length you get one sound. Let the level water go down. It is going down. You will get the sound again here itself. To find the average, now when you are noting the position here, you may commit mistake. So then you take the level up from bottom. Then again level of water will increase, and again you will get a loud sound here and here. Take the average of 2, you will get L1, L2. Actually, I have seen in lab, student strike the tuning fork on rubber pad and go like this. No, this sound is heard from a large distance. Now, so this way, velocity of sound will be obtained at room temperature. And we know that Vt is equal to V0 plus 0.61 T. So if we know Vt, we can find out V0 from this by measuring temperature of room. Nowadays temperature of room will be nearly 13 or 14 degrees centigrade. So this approximation is true. So you can find out the speed of sound using resonance tube at room temperature and at 0 degrees centigrade. Now this L2 is slightly more than 3L1. Why? The relation of and effect and correction and L2 L1. From figure 1, lambda by 4 equal to L1 plus E, or lambda equal to 4 L2 plus E. From here L2 3 lambda by 4 हो गए, lambda by 2 plus lambda by 4 is equal to E plus L2. Lambda by 2 plus lambda by 4 comes out to be 3 lambda by 4. Lambda by 2 plus lambda by 4. If you take LCM 4 2 lambda plus 1 lambda, so 3 lambda by 4. So 3 lambda by 4 is equal to L2 plus E. L2 plus E, or lambda is equal to 4 upon 3 L2 plus E. 1 and 2. Comparing 1 and 2, we get 4 L1 plus E is equal to 4 by 3 L2 plus E. This 4 get cancelled. 3 L1 plus 3E is equal to L2 plus E. Or further 2E is equal to L2 minus 3L1, or E is equal to L2 minus 3L1 plus 2. So please be careful when you are taking position second resonance. This L2 should be more than thrice L1, slightly more than. If it becomes less, then it means antinode is formed inside the tube, which is not possible. That always form up. So please, you can read the books for more explanation, but I have explained you very clearly. This is one experiment in the lab in class 11. But unfortunately, I have noticed that students do not go to lab, teacher are not serious nowadays. Please go to lab, you will learn so many things. When you see them happening, physics or science is live subject. Please learn the thing properly. Now I have completed this. Now I will be telling you some numericals. One numerical I did in previous video. Now one few more are there. A big number of numericals are there on this vibration of there is simple question here for sake of practice. The length of open pipe is 50 centimeter. The length of open pipe has length 50 centimeter. If speed of sound V 330 meter per second, then find fundamental frequency. Just for practice, find the fundamental frequency. What will be the fundamental if one end is closed? पहले ये ओपन था, जिसकी लेंथ 50 सेंटीमीटर थी. If the one end closed, then what the frequency? For open pipe, fundamental N1 equal to V by 2L. So V 330 or 2 into 50 centimeter, convert that into meter. 50 like this. So it becomes 1. So it is 330 hertz. 5 to the 10. Simple question. Now, for if it is closed, then for closed pipe, N1 equal to V by 4L. यानी कि हाफ ऑफ 330 यानी कि 1/12 इंटू V/12 और V/12 will remain 330 हर्स तो it is 2 1 या 2 6 या 5 just for sake of practice. I have noticed the student avoid of doing numericals because their arithmetic is not up to the mark. Please, all these mathematics or everything is learned by practice. In music, I have seen students practicing a lot the whole day. They keep on क्या बोलते हैं प्रैक्टिस करते हैं पूरे दिन. Then they are able. Sometimes though, when school function there, their throat is disturbed, so they have to do gargle and so many things, and then they have to perform. Actually, when we perform before people, we are conscious, we are very serious. But when we do it alone, or let it be, कौन देख रहा है, वो नहीं चलता बच्चों. Please do practice of numerical. Only by doing numerical you can learn. अब मैंने लिखा इसको, आपको याद होगा कि फंडामेंटल फ्री ओपन पाइप V/12, क्लोज पाइप V/4L. I have told harmonics that in open pipe even odd harmonics are produced, in closed pipe only odd harmonics. Now there is another question here. The difference between frequency of second overtone of closed pipe यानी कि the difference between frequencies of second overtone of closed pipe and first overtone of open pipe of same length equal to 150. Difference of frequency of second overtone of closed pipe and first overtone of open pipe of same length is 150. What are the fundamental frequencies of closed and open pipe? Here one is closed pipe, another is open pipe of same length. Second overtone of closed pipe, the fundamental N1 V/4L था, N2 3V/4L था, and it was first overtone. So second overtone of this N3 5V/4L for closed pipe. You can do like that. Open pipe के लिए N1 was V/12 first harmonic, N2 V/L second harmonic और first overtone हो गए. So here you are given that the difference of frequency of second overtone of closed pipe यानी कि 5V/4L minus first overtone of open pipe V/L is 150. So you are asked what is the difference, what are the fundamental frequency. If I take V/4L common, it is 5 minus, actually common, to take common means divide. If we divide V/L by V/4L, so we cancel, so it will be 4 150. So V upon 4L equal to 150. What is this? Fundamental frequency. hence fundamental frequency of fundamental frequency of closed pipe 150 hertz, and that V by 4L है for open pipe fundamental frequency V by 12 यानी कि twice of this 300 hertz. So that way these questions are a good question. You please practice. I will be telling you more questions in next video regarding closed pipe and open pipes. Thank you.